the way that you interact with Spawn is through the command line. So already here, I've actually created a image while we were all talking just a second ago. The reason I did this in advance is because it's using a backup, so it takes a little bit longer. As Santiago was saying, the image is the piece of the process that kind of takes the most amount of time. So that's creating something from a backup or maybe from a scripts folder. The point is that once you have that image, you can then create containers very quickly. So let's have a look at what this YAML file contains. I'll open Visual Studio Code. And this YAML file is kind of all you need to get started with Spawn. So here I'm defining a data image where the engine is MySQL. And I'm calling it MySQL Backup because the source type, as you can see, is also a backup. And I've also said that the backup folder is in this directory. That's what the dot means. And then the entry script, i.e. the thing I need to run to start the restore operation, is called dump.sql. And we can actually see that file here in the same directory. So this is a MySQL dump file. So this has come from running MySQL dump on an existing MySQL database. This is normally how people create the backups of their databases. So you can see here there's a bunch of output. It creates a database called large. It then creates a table called large table with just some varchar columns. And then there's a giant insert script which just contains all the data. So that's pretty much it. I'll jump back to the terminal here. So you can see all I had to do was say spawnctl create data image, and here you can see that it uploaded the two backup files and then created the image, and I have one ready to go. So I can have a look at the images that I have now. And you can see that I created one an hour ago and also this one 9 minutes ago, just at the start of this office hours. So at this point, the data image is kind of like a read-only version of my database. So I can't connect to it. I can't make any changes. I can't actually do anything to it. So in order to do that, I need to create a data container. So we can do that by using spawnctl create data container and tell it which image I want to create it based off of. So here I'll use 10508, which is the most recent image I just created. And here you can see that it'll create the container, and it's very quick. So already I now have a connection string that I can use to connect to that database. So I'll jump over to another terminal tab here. I'll just grab that port, which is 53223, and connect to this database. Let me just remind myself how this works. Instances.spawned.redgatefoundry.com. Port is 53223. The user is root, and the password is the one that was generated in here as well. So we have that there. And if I paste that, you can see that I've now gained access to this database. So I'll switch to the SQL prompt here, and I can actually have a look at what databases I have in this container. So you can see I've got that large database that was defined in the MySQL dump file. And then I can actually go into that database and show me the tables in there. And sure enough, I have the large table. If we see how many rows I've got in there, you can see I've got all of the data as well. So at this point, I can start making changes to the database just as I would any other instance. So maybe I can create a table called foo and just create it with just an ID and maybe insert into there a couple of simple values. So now I have two tables, the original large one, which came from the backup, and this new foo table that I've just created. And again, obviously, I've got the data in there as well. So at this point, maybe this was a significant change, and I think that it's a good place to kind of checkpoint the work that I've got in this container. So I can do that by jumping back to the spawnctl and saving the state of the data container. So my container ID here is 10292. And what that does is it essentially gives me a new revision of that data container. So I can now come back to this state if I want to come back to it and make some changes, or if I accidentally make a mistake, I can reset back to this point. So I'm still at the same container here, and what I'm going to do is I'm going to truncate that large table. So I'm going to delete all the data out of it. So now if I select everything from the large table, you see that I've lost all my data. And at this point, what I'd probably have to do is restore a backup that I had in the past, and that would be the quickest way or the most efficient way for me to get that data back. but that obviously can take a long time depending on how much data you have. So with Spawn, because I saved that revision, I can actually reset and take myself back to all that data that I had before. So I can call spawnCTL reset data container, and what that does is it takes me back to the state I was in before I accidentally made that mistake. So sure enough, if I show the tables, it'll reconnect to this instance. So it's using the same connection. And there's my large table. And if I count from it, you can see that I've got all my data back. And I didn't have to do a long restore operation to do that. So at this point, I might want to actually create another table. Let's call it bar. And again, we'll just insert some simple data. And that looks good. So now I've got 3 tables, the one from the backup and the 2 that I've just created in this container. And again, what I might want to do is save that state to give me a new revision because, it's a sensible checkpoint to make. But at this point, if I was to delete this container, I would lose all of the data and the revisions that I have. So, maybe I want to be able to come back to this at a later date. We expect these containers to be short-lived, so we need some way to take that data forward and be able to use it in the future. So the way to do that is to graduate a data container. So I want to graduate the container 10292, and the revision I want to graduate is the most recent one, rev.2 that I just saved. So if I call that command, what it will do is it'll actually create me a new data image based off of the changes that I've made on this container. So now if I have a look at my data images, I can see that I've got this graduated one at the bottom. And you can see the source type is now graduated instead of backup. So at this point, I can actually create another data container that's based off of that new graduated image. And again, this will be a very fast operation because we're using differential disks, and sure enough, I've got another instance I can connect to. So I'll just copy this connection string to save me a little bit of time. And obviously, because it's from the same image, the credentials are the same. The only difference is that I've now incremented the port by 1 because it's another instance. You can see that here. I'm on 53224 instead of 3. So if I connect to this instance, you can see, let me just switch to the SQL tab. You can see that I've got the large table again. And if I move into that database and show the tables, I've got both bar and foo that I graduated from the previous container. So this is based off of the backup file that I created for the first image, but I've also taken the additional data and schema that I made in the originating first container. And these are 2 separate instances as well. So if I want to drop the table bar in this one, and maybe I want to drop the table foo here as well, and show what tables I have, sure enough, I've only got large table. But if I go back to the original container, the first one that's still running, and I go back to the large database and show the tables, I've still got all 3 tables because they're 2 separate instances. So hopefully that shows kind of the power of Spawn and how you can quickly spin up containers based on backups or graduating from other containers. At the moment, the backups only support MySQL and Mongo because those are the 2 engines that we're supporting for the concierge users we have. As time goes on, we expect to support Microsoft SQL Server, hopefully Redis as well, and PostgreSQL, which are the other engines we support at the moment.